Welcome to Tech Captains, where we dive into the latest in tech innovation and leadership. I'm Ron Dannenberg, and with me today is my co host Gareth Thomas. Today, we're thrilled to have Stephen Blum, the CTO and founder of PubNub. So, Stephen, thank you for being here.
Yeah, it's great to be here. I'm looking forward to chatting with you today.
Thank you. I mean, with over 14 years at the helm of PubNub, you've been instrumental in shaping real time communication infrastructure used across various industries, from telemedicine to multiplayer gaming. Before PubNub, you led system architecture at Loyalize, developed software at Microsoft, founded another company called LTS Yavo, if I pronounce correctly, which was your first company created as a real-time CMS.
That's right. Wow, I did not
Uh,
think you would go back that far. That was amazing.
and yeah, I mean, we're excited to learn from your experiences, insights, especially focusing on your PubNub and how it has grown from to become a go-to platform for building and operating real-time interactive apps. So let's get started. I want to start. I want to go quite technical with you today because you're very active on LinkedIn, maybe other social medias, I don't know. But I've seen there that your posts are quite technical, and that's actually how you today in the show, responding to a comment on one of your technical posts. And I want to start with the real time data stream network that you have. I don't know if you could maybe start by elaborating on the architecture of PubNub's real time stream network and the key challenges you face in scaling it to handle billions of devices.
Yeah, that's a great question. So PubNub is the world's largest global publish subscribe network, and we are now a complete developer platform, which allows our developers to use the publish subscribe APIs to do the things that you were already mentioning at the call. I was surprised that you were jumping in some of the use cases, right? Multiplayer gaming, and we have if you've ordered food, you have probably used PubNub for the delivery to see the car moving around on the map. You also have if you have a Samsung TV. We have an open active connection on Samsung TVs, and we have over 1 billion devices connected to our network.
Oh,
That's
wow.
huge. That's a lot of devices. There's so
A
few
lot.
businesses make it to that billion mark, right? It's just a big number. It's a really big number, and that's where the challenge came in. Like you're describing from a technical perspective, our message bus is written in C for high efficiency. We even have optimizations in the assembly layer
Hmm.
for a lot of the encoding and transit of the data. And there's no way that existing technologies like traditional load balancers have a hard time dealing with always on active connections. That's a hard challenge. And
Yeah.
even trying to get that to work in Kubernetes, we had we had a lot of fun with that one. And that's some of the challenges that we've had. But I'd be happy to dive into more details if you have any questions.
Yeah, I mean, how do you ensure like low latency and high reliability in real-time messaging across a global distributed network? I mean, I've seen, yeah, there's your statement of reduction from 120 milliseconds to 30 milliseconds writing time. I'm sure this had a big impact. Is it just like you switch programming languages, or you just adapted, the script, the algorithm that worked? Like, what did you do?
Yeah, well, first you have to pick the right technology and approach. When we wrote it in C, that wasn't the first language. We started, with Node.js when it just came out, and it was very unstable. It worked okay up to like 2,000 users, and then there was problems. So we had to quickly re-architect it to C and
I see.
use the right event loop manager, right? And so using, we have a lot of kernel APIs that are available to on Linux, so you got to pick which one from an IO perspective are you going to use, and we chose epoll. So we used the epoll APIs for network-driven interruptions that allow a cooperative processing in C. It turns out you can have extreme high concurrency when you use that kernel API, and we've leveraged it. And it goes even further to get the 30 milliseconds you're describing. You
Yeah.
can't just have one server running in a data center and all users connect around the world. You have to have it has to be globally distributed across all the data centers. So everywhere, different continents, different countries, we have to do that. And then users connect to the closest region, and that's how we're able to achieve such excellent latencies.
And it was interesting to me because I was reading about some of the sort of use cases for your platform, which I was amazed at actually at how many there actually were. And there were some that, I hadn't even considered before, like sporting events, real time statistics for sporting events and stuff like that. It almost feels like, how did we build anything before you existed? you know
Yeah.
how was anything so where do you go next with this? Because like I said, when I looked at all those, I thought, well, it's kind of extraordinary the cover that you actually have with this solution.
Yeah, absolutely. It's the orchestration is the big challenge. So you can definitely build this yourself today with like Socket.io. That's one of the options. You can host a
Mm-hmm.
Socket.io server and have users connect into it. Load balancing becomes challenging, and then sharding becomes challenging, and it's a big challenge, especially at the large scale. Some of the opportunities that live events love PubNub for. That's why they love PubNub, is because they can spike up instantly. And so we've orchestrated our C infrastructure to run in Kubernetes in an auto scaling environment that matches the demand in the latency expectations that is necessary for sporting events. And that's where we got started, a lot of sporting events. And so we really had to make sure that we had the capability to do that. And so we do offer that tech today for sporting events.
And just actually going back, because you said you started out, you wrote it in, I think you said Node.js, then you moved to
That's
C,
right.
and then I think you quickly said, oh, and we have some handwritten assembler within that as well. Was I right in hearing that?
Yes, a lot of the serialization that occurs between our routing layers actually runs through some assembly optimizations.
Wow. Yeah. I mean, there probably aren't that many
Yeah.
people these days writing, the 86 assembler, right? In the nowadays, I mean, people are so far removed from that kind of level, aren't they? Normally.
Yep, you got it. Yeah. And even the compilers, they do a really good job today, even modern compilers. So they still add a few extra instructions that you can eliminate and optimize out. So it gives us an opportunity because there's over 3 trillion JSON payloads per month go through our network. That's a lot of JSON. And so in order to process all that from a serialization perspective, the fewer instructions that we have running on every single character, the better.
What kind of database do you use for that?
So we use Cassandra to store those JSON messages for customers who like it. We like Cassandra because it's time series, which is very similar to how a pub subsystem works, right? You have a linear stream of data over channels, and you want to store those JSON messages as well. We like Cassandra because it matched our globally distributed model. We can deploy the Cassandra databases in all the regions and have copies of the data in every single region. This is our failover story as well. It allows us to reroute via DNS where customers might need to route to if they have a failure in connecting to the closest region, right? So their data is always available.
And I'd like to dive a bit more into security measures. So, PubNub, I mean, obviously you implement end-to-end encryption and various security protocols that are quite standard today. But can you maybe describe, obviously, I suppose to up to a certain level, the specific security measures in place and how they protect it against potential cyber threats?
Yep. So we offer several security options for our customers today to secure their data channels, right? You want to essentially have uh, a model that allows our customers to define what permissions go to what users, what user IDs, and what resources they have access to. It's actually not much different than most systems, right? Most user driven permission systems, even identity access management, for example, with Amazon, you'll have the ability to set permissions on what users have access to what data. And we offer that as well. We even go further in saying you can read data, but you can't write data, or you can write data, but you can't read data. If you wanted to do it that way too, you could. And so we offer
Yeah.
that level of flexibility to our customers.
You've mentioned I think that on your LinkedIn, the importance of rapid deployment, customer feedback. And so I'm really wondering because with the monster architecture that you're describing right now, in the sense that it's so distributed heavily in so many different places and different servers, how does PubNub balance the need for quick releases with the need for thorough testing and reliability, like in this distributed environment?
So we do have there's a lot. That's the biggest question, right? Because you have CI/CD unit tests, integration tests. spec test, mech test. You have all these testing systems that are set up to make sure that everything is not regressing, right? So of course, all tests have to pass before we put out a release, and we want to make sure to have 100% test code coverage. We do those, good hygiene practices that we have in engineering. We go further, of course, with smoke testing, right? You want to see how much load can occur on the system before it breaks, and then what are the scaling points that we can throttle in. We have the ability to, when we deploy into production for live customer traffic, we do two options first. The first option is we're really confident and we know it's going to be fine. It's a lightweight change. We'll just roll it out to a percentage of traffic, right? Common industry standard. And then we'll do that. We'll trickle it in one of our data centers, and we'll trickle a few more, and then global. So that could happen over a day or several days, depending on our risk tolerance. And the other one is traffic mirroring. We can just mirror traffic to the service in staging environments and make sure that it matches one for one the output that we see in production. And so that's another approach. For the riskier deployments, we'll do that first.
And that last one, I was actually going to ask you a question on that. So that is because you did a video quite recently about testing in production. I think quite like a week or so ago that I watched. It was really good, and you were talking about shadow service testing, and I wonder how many people in a lot of companies know what that is, and secondly know how to implement it, because most people would understand using canary releases and feature flags, testing front end changes, right, and deploying those. I don't know how many people would actually go through and understand how to implement such shadow service testing. So can you talk a bit more about the service that you did this with and how you did it?
So we were just talking about security and authorization. That's a huge aspect to our network because every single API call needs to match this service. It makes a call to it, makes sure that it can go through. Mm-hmm. So we call that a subordinate request, where it verifies the token and the permissions. We rewrote that in Rust because it was time to do it. we needed the upgrade, and it was a big win for us because it was a significant performance improvement as well. And so that is a very high risk scenario. We want to be able to mirror traffic in that scenario. It's hard to do that. Here's why: because it's actually pretty straightforward to throw traffic in two directions. I'd say that's pretty straightforward. That's like the first step. Mm-hmm. The next step is you have to go back and compare. And there's extra work there. And there's no systems that really do that. So you have to, write extra code to test and look through to make sure there's a matching on those and matching things up. That's the more challenging part.
Yeah.
That's the hard.
Yeah. I was at a company quite a few years ago, and we actually did shadow service testing, but probably not on the volume that you're doing it. And we were doing it for a service that was, I think it was generating some kind of audit logs as I remember it. But you're right. I think the difficulty was figuring out how you can again do this comparison and understand where to find the problems, right? That you're going to go fix them. And yeah, I can't really imagine doing it on a service where you said, was it 1 trillion JSON a day? Was that a day that you're sending around your service?
It's about 25 petabytes of data per month, which are around over 3 trillion messages per month.
Oh, 3 trillion a month. Okay. With a T. Yeah. It's still extraordinary. Okay. Yeah.
It's a lot. It's a lot of data.
And so that introduces my next question quite well. Like, what is your approach to using conflict-free replicated data types? I found that term in preparation for this call, and I had to Google it first because I knew the concept, but I didn't know the term. So what's your approach there? So the acronym is CRDT in building collaborative applications like, for example, real-time text editor. That's a classic example. Two people are writing, the internet connection is not the same speed. You want that to reflect real-time, and they're both clashing.
Yeah, CRDTs are amazing. I love them. Excellent technology. It's fantastic because it matches our style of how I love to deploy software, right? I'm business focused. I'm business minded. I want to make sure that the hardware I purchase, the hardware that I lease, is going to be in use continuously, and we don't have standby hardware that's sitting there just in case, right? Because I'm throwing away money. I'd much rather have a system that can route traffic that needs to systems I'm paying for and I'm actually using them. And so CRDT, the same design pattern, sort of is enabled by that, because anywhere in any of the nodes or any of the writers, you can write data and you can read data, and there's no like primary, right? There's no central system that's required for this.
Yeah.
You can have a distributed system. I love that. That's my favorite because it allows us to scale, has a better tech. And so with
How do they
CRD,
work? How do they work?
oh, so it's like operational transforms. If you're familiar, it's another approach that's like the original Google Docs pattern. It's very straightforward. It's just at the simplest level, it's you need a message bus that's reliable, like PubNub, right? So you have some guarantees there, and then you have on every side you have a domain ID, so user ID, right? Who's typing text onto a collaborative document, and every keystroke or every so often you'll it'll transmit a sequence ID, the user ID, and the change. And it's really that simple when it comes down to it, because now both sides know, okay, I have user a b 123, I have user 123 over here, and I have their sequence, and I know I might have missed a sequence because I was offline for a while, so it can go back and fetch the sequences. So it gives them sort of a commit point, if that makes sense, because it's really straightforward, really simple.
So I was going to say, so you just said something there that intrigued me, and maybe I misunderstood. You said that you purchase servers. Mm-hmm. So are you co-locating or buying physical servers as opposed to using public cloud, or are you using a mix of public cloud, or did I misunderstand you?
All right, so clarification. We run in Amazon, so we've leased their servers. So instead of purchasing, right, where you buy the hardware, we've leased our servers with Amazon.
Yeah.
We could save a lot of money, though.
Yeah. I was just the reason I picked up on it, because that quite a few big cases recently, haven't they, of companies going back to physical servers, co-located servers off public clouds. Was it Basecamp or one of the most recent ones, I think, not that long ago?
Yep. Yeah. 37 signals, yeah.
In
terms of like future trends and vision, like in your opinion, what are the next major technical advancements that will impact real-time data streaming and communication? I mean, in so many products that you use, B2C or B2B, many people now expect to have real-time.
You're right. It's expected today. That's because if you look at the top 10 apps in the App Store right now, they all have built-in communication, every single one of them. And that's what we provide. We have an API and SDKs for every language that let our developers build in-app communication. It's like messaging, delivery, you name it. And so where do we go from here? What's the new tech? How does it evolve? Something that we're working on is making sure that we support latest protocols and technologies, something like web transport. That's like the next generation. It lives on top of Google Quick, which is HTTP2 and HTTP3, and that's something that we're investing in right now. And we, of course, we're using Rust, right? We're doing that, and so that's where we're going from there. It's sort of like the next evolution from WebSockets to web transport, and so that's some of the investments that we're doing there for real time.
And how do you see the role of AI evolving in the tech industry, and particularly to your industry of real-time application development, if any?
So we're doing it based on customer demand. Our customers are asking, because they have so many messages going through the system, a human or a team of humans can get really expensive. So if we can automate it with an AI that's trained based on the data that's going through the system, something as simple as moderation, right? We were just talking about live sporting events. There's a lot of chatter that goes through. Right now, a lot of that is moderated by humans. And so our customers are actually asking us, hey, can you just click this button here, and it automatically takes care of the moderation. Either it hides the message and says there's sensitive, potentially sensitive message, or just remove it from the stream altogether.
I see. So you go one step above the just transmitting information. You actually can do some processing when it's in flight.
Yep, exactly. Yeah, and so there's a lot of use cases for that. And we're working with existing customers that have that scale, that are looking for us to help them with that.
And we have usually a tradition in the podcast that the guest would recommend a book. And ahead of this podcast, you send actually a whole list recommended by Y Combinator on the website. We will add it to the description of this podcast. And you say that your general advice is Don't wait to start a business until after you feel you have enough knowledge. It's too late by then. Start right now, learn along the way. And that's raised, we spoke with Gareth in advance, and a book that was recommended by a former guest, but I let Gareth speak about it.
Yeah, so I was looking through the list and I picked up on the mom test, which was written by Rob Fitzpatrick. I don't know if you read that book, but there's if you just read the little bit of text on Amazon, it says they say you shouldn't ask your mum whether your business is a good idea because she loves you and she will lie to you. This is technically true, but misses the point. You shouldn't ask anyone if your business is a good idea. It's a bad question, and everyone will lie to you. So basically, they're saying talking to customers is the key thing. So this was we interviewed a lady called Janet Maldonado last year, and she recommended the book. And what was funny was I read that and I thought it's very true because quite a few years ago I lived in California. I had a software company, and my mum kept telling me, "You're going to be the next Bill Gates." And she would tell her friends, Gareth's going to be the next Bill Gates. Well, clearly I'm not the next Bill Gates, right? So mums do lie. Mums do lie. So my question to you is, did you ask anyone about whether PubNub was a good idea, or how did you sort of validate the idea for it when it came to you?
Yeah, when you jump right in, you kind of, you launch the business, you put it out there on the internet, and you hope that people come, and you realize that no one's coming. No one's going to come. You have to spend a lot of time on market, right? It's just there. No one knows about it. So you have to promote it, and you have to spend time on showing how it's powerful and how it's useful. And that kind of thing is the kind of mentality that you need. So this is why, like, for example, customers are so important. You need to be able to get in front of customers like you're describing. They're going to give you their honest opinion of what is painful, what hurts, what's really painful and annoying. They need to be able to do XYZ, and it just takes them a lot of time and effort, and they would gladly pay money to get rid of that pain, right? That's what you want to hear from a customer. Like, oh, thank you, you're helping me solve this painful thing. It hurts a lot, and now you're taking it away. Well, I love that. Here's money. Right? You just go that approach.
Here's money. Take my money. Yeah. So at what point did it? I mean, obviously, so you launched the business, you put PubNub out there, and I'm guessing for a few years, whatever, you were busy like trying to get people to come on board. At what point did you sort of reach the critical mass that it almost started to sell itself through customer recommendations? Was there kind of a number? Was it like 50 customers, 100? Do you have any sense of when that was?
Yeah, we hit maybe like the first day of 1,000 signups, a couple months in, and that was like the biggest signups day ever. It was just, wow, this is amazing! So many signups, and we got some press on some new sites and things like that, and that sort of sparked my passion as well for helping promote products and really getting out there and talking about it. And that's really key. Like, how much time do you spend on promotion? That's a really good question, because you want to have a really good product, but you can have the best product no one's ever heard of, which is terrible. So I would say 90% of your time should be spent on promotion.
Right. And I would say, actually, one of the things I found amazing was, again, I watched your videos. I started watching your videos. Your videos are so engaging. You're so passionate and enthusiastic about your company and your product. It's like you want to keep watching your videos. And I think that's a real lesson for a lot of people today is being out there doing these kind of things, right? And getting your message out in front of people, because it's great. It's really interesting.
Absolutely. And it helps a lot to be excited about it as well. If I mean, this is something that you want to do and you wake up, it's the thing you want to do because it really is exciting. It's
the thing you want to do.
There you go. That's a good.
Yeah. There was another video I watched of yours, and you were talking about, build versus buy. And you said you have more vendors than employees yourself, PubNub, which I found that kind of extraordinary considering your scale. So, of those vendors that you use, how many of those have been there from the start since you started building it? And do you find that that's a mix that's constantly in flux? I mean, are you sort of constantly evaluating, looking, is there somebody else that can do this versus someone else at better price point? Or
that's a really good question. So each team and employee, they have goals and objectives, right? And so it's a lot cheaper and better even to hire a vendor to take care of something because they've got the expertise and tools and systems they've optimized specifically to achieve whatever goal like the team needs. And so the more we can do that, the better, because that allows us to scale the business more quickly. It's easier to scale those tools. Uh, so it's really up to the teams that to decide what tools they need to add in. It's much better to do that rather than hiring a dedicated person. Because one of the questions I think that we were thinking of talking about was team structures. How do we do that? So my most important thing is make sure the team has no dependencies with other teams, because that'll slow them down. It always slows them down. It reduces the speed of because now you're splitting focuses and they all have different goals and outcomes. And so it's much more challenging to have a successful team delivering if they're if they have conflicts, right? So which one do they work on? Oh, this team needs help over here. So it's better to have vendors that can help solve those problems of any missing dependencies.
You're buying a specialism, aren't you? I mean, I remember again a company I was at that they built their own CMS, and we ended up spending a whole bunch of time moving off that. I know. I mean, list of things you should never do. Never work. If you're an actor, never work with children or animals. If you're in technology, don't go and build your own CMS, right? So you're buying that specialism, and then kind of related to that, which is interesting today. So I've been looking for a feature we're actually building where I am, right? I was evaluating some low code and no code platforms and looking at some options where we could use that for our product people to build a feature. But one of the things I noticed, which hadn't occurred to me till I really looked at it, is how proprietary a lot of these platforms are. You're very closed in, which I think they have to be to make the process of building easy. Now there are some that have stepped outside that, where you can extract out what you've built, whether it's JavaScript or whatever it is, and run it yourself. But most are very closed platforms. So I'm just wondering what your thoughts are around that. When you're we've got this massive change now with generative AI, which I think is feeding into the low code stuff. How do you see some of that stuff fitting into perhaps into PubNub? And what are your thoughts on these kind of proprietary closed platforms and picking one of those solutions?
Actually, that's a really good point. So when it becomes vendor selection time, right? What in the evaluation cycle, is it how dependent is the business going to be on that technology? That's an important aspect. Is there a switching cost later in the future? Is there are we going to back ourselves into a corner? It's scary because you don't want to get into a position where you are stuck, right? Where you can't escape. But at the same time, as if you're building a product, you need to get out to market quickly. So things, for example, charts and graphs, really simple and easy technology can be significantly streamlined if you use a vendor or an open source project. And so that's something that you wouldn't want to build. You want to pull in, either buy or install from an open source perspective. If it goes something like Atlassian, that's a good one, right? Where you have a Jira, Confluence, and Wiki, and those are pretty standard. And we have that Salesforce for CRM. And now are you thinking more along the lines of APIs and other kinds of things like that? Like, what are you thinking in terms of vendors?
So we were looking at basically what we wanted to do. We wanted to build a new feature for our platform, right? An additional product feature. And this was to be some software that we wanted to prove with our customers. And the thought was, and when I started looking at these, I'm like, well, actually, the capability is that a product person, not an engineer, could bolt something together very, very quickly to actually prove the concept, show it to customers before we then go and hire a bunch of engineers to go build it, right? But then, like you say, the problem being you're stuck there in this place, and you end up with something that will look great, do a really good job, but you can't then take it off that platform, take it somewhere else if you need to. I mean, a lot of these companies are VC backed. Who knows if they're going to be around in 3 years, 4 years? What's going to happen, right? What do you do then? And like you said, if this is strategically important, and this company just disappears overnight, what do you do? And that was the place we found ourselves. And so we're probably going to use it for a POC, but beyond that, we're going to build it the old-fashioned way.
Yeah, once you have that control, that level of investment is necessary because it's a core of your business, right? So you need to be, like, for example, hosting servers. Even though we spend over $10 million per year on servers, that is not. I mean, we could go out and buy servers from, and $10 million would buy a lot of servers, right? And that would just be one,
Or buy a lot
right,
of servers.
and it would be less than the cost for Amazon for a whole year, and then we could keep using those servers for many years down the road. So it would be a huge cost savings from that perspective. Just the level of ease and the ability for us to be nimble and scale up quickly is, one of the powers of the cloud. But it does come at a price. It is expensive.
Would you ever think of building your own servers to some of your very specific use cases?
Yeah. In the early days, we were even looking at ARM processors that were, only in phones, and we're like, those are going to be really cool to run as servers. Why don't we do that? Like, a decade ago, that was way before they were really available commercially. And so we were thinking about just running a bunch of phones on our because our software was really efficient, and we just needed concurrency, and we could totally do that on ARM processors.
To conclude this podcast, what would you recommend to anyone joining the tech scene as an engineer, and they're just starting, they're looking for the first job, or they just joined the first job? What piece of advice you would give?
Ooh, it depends. Like, where are they going in their career? What is what are they really looking to do? What is their goal, right? How far do they want to go? If you're just starting, really, something you can't learn in school is just starting to build and work in a business to build a product, or upgrade product. Those are things that you'll just learn new things that just don't happen in school. Uh, so potentially, if you're brand new, try to get an internship as soon as possible, right? Or if you have joined a company, and is that the phase that you were talking about? So you've already joined the company. Like, what do you do next?
Yeah.
Sort of thing.
Yeah.
Talk with different people at the company. Try to set up meetings. Salespeople and product people will have a lot of insights that you might not necessarily get just by working with your teammates who are other engineers.
That's a good old-fashioned advice that always works, to be honest, to get out of your bubble. But Stephen, on these wise words, thank you so much for joining us today.
Yeah, absolutely. It was great to chat with you. Thank you.
Thanks, Steve.
Thank you. And for everybody listening, we'll be back in 2 weeks. Bye-bye.